Day 628 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3315. Construct the minimum bitwise array 2. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an array nums consisting of n prime integers. You need to construct an array ands of length n such that for each index of I, the bitwise OR of ands of I and ands of I plus 1 is equal to nums of I, i.e. ands of I or ands of I plus 1 is equal to nums of I. Additionally, you must minimize each value of ands of I in the resulting array. If it is not possible to find such a value for ands of I that satisfies the condition, then set ands of I equal to -1. All right, y'all, so that sounds simple enough, but now that we have read the question, let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So in example 1, we have our input nums equals an array of integers 2, 3, 5, and 7. As you can see, these are all prime numbers. Right here it says a prime number is a natural number greater than 1 with only two factors, 1 and itself. So as you can see, these are all of our prime numbers that they've given us right here in our input array. The output is an array of integers -1, 1, 4, and 3. Explanation says, so let's see how we got this output. It says, for I equals 0, as there's no value for ands of 0 that satisfies ands of 0 or ands of 0 plus 1, which would equal 2. So ands of 0 is equal to -1. So that's where this -1 comes from. Now, I know that may seem a little bit confusing, so I'll explain what that means. It'll be easier for me to explain what they mean by that when we look at this second example right here. So for this second example, it says for I of 1, which is index 1 right here, which is 3, it says the smallest ands of 1 that satisfies ands of 1 or ands of 1 or bitwise or ands of 1 plus 1 is equal to 3 is 1 because 1 or 1 plus 1 is equal to 3. So let me go ahead and break this down for you one step further, right? So right now we have 3, right? And the output is 1. So that means 1, when we do this operation right here, 1 or bitwise or open up the parentheses 1 plus 1, right? Because it says right here, ands of I, bitwise or ands of I plus 1. So that's what this is right here. Ands of I is 1, bitwise or, then ands of I is 1 plus 1, right? So boom. So that would turn into 1 bitwise or 2. Boom. So let's see what that what happens when we compare 1 bitwise or 2, right? So and binary 1 would be 001, then we could say 2 would be 010. So when we compare these, right, using this bitwise OR operator, that means when we compare these bits, if there's a 1, then that means it's going to return a 1. I'll show you what I mean by that. So and we're going over what this OR means right here, what this bitwise OR is. So 0, 0, that would be, when we compare two zeros, that's going to be a 0. When we compare 0 and 1, that's going to be a 1. We compare 1 and 0, that's going to be a 1 because there is a 1 in this comparison, so we put a 1 here, and there's a 1 in this comparison, so we put a 1 here. So hold on, let me clean this up. Boom, 3. Boom. Then, so that's how, sorry y'all, so that's why we put 1 right here. Boom, because when we put 1, that satisfies the conditions, right? It equals 3. Index 1 is 3, so we put index 1, we'll put a 1 here. Now, let me show you something else, because say we put a 2 right here. A 2 right here would also work, right? So if we put a 2, that would be 2 bitwise or open up the parentheses 2 plus 1, right? Because once again, it's ands of I or ands of I plus 1. So 2 bitwise or Then 2 plus 1, that's going to come to 2, bitwise OR 3. Boom. So what does that look like in binary? In binary, that would be 010, and then 3 would be 011. Now you can see, once again, we have two zeros, that'd be a 0. It's a 1 in this comparison, so that's a 1. It's a 1 in this comparison, so that's a 1. So as you can see, hold on, this would be 2, this would be 3, and this would be 3. Boom. So as you can see, it would also work if we put a 2 right here. That would also satisfy this condition for this 3, right? However, it says right here we want to minimize each value, so that's why we're going to use the 1, because the 1 works as well, and 1 is smaller than 2, so that's why we'll put the 1 right here instead. Boom. So let's keep going. We get rid of this. Now we're right here at 2, index 2, index 2, which has a value of 5. So the answer will be 4. Let me see. It says 4I equals 2, the smallest ANDs of 2 that satisfies ANDs of 2 bitwise OR ANDs of 2 plus 1 equals 5 is 4, because 4 ANDs of bitwise OR 4 plus 1 equals 5. So let's go through that, right? So it would be 4 bitwise OR, open up the parentheses, 4 plus 1. Boom. Then it would be, so that would be 4 bitwise OR 5. Boom. Then, so let's go look at the binary, right? So binary would be 4 would be 100, so we'll say that's equal to 4. 5 would be 101, that equals 5. Boom. So once again, when we compare these, it's a 1 right here, so that's going to be a 1. These are zeros. Boom. That's 0, 1, 1 equals 5. Boom. So as you can see, this 4, or excuse me, this 4 satisfies these, satisfies these requirements right here to get us 5, just like this when we compare them using the bitwise OR. So boom, the 4 checks out. So let's look at the 3. So, and index 3. So for I equals 3, which would be this 7, the smallest ANDs of 3 that satisfies ANDs of 3 or ANDs of 3 plus 1 is equal to 7 is 3, because 3 or 3 plus 1 equals 7. So let's go through it, y'all. So once again, we're going to start right here, and we're going to say 3 or, open up the parentheses, 3 plus 1. Boom. So once again, that's going to come into 3 or 4. Boom. So let's see. The binary representation of 3 would be 011. Binary representation of 4 would be 100. And then when we compare them using the bitwise OR, it's going to be 111, right? Because it's a 1 in this comparison, it's a 1 in this comparison, and it's a 1 in this comparison. So it would be 111. 111 is equal to 7. Boom. And that's what we want, right? Because this is 7. So 3 satisfies that condition. So that's how we got this output, -1, 1, 4, and 3. So once again, there was no number that would satisfy the condition when the value is 2. But so that's why we put -1. All of these, we were able to satisfy the condition with these numbers right here. Boom, y'all. So I hope that makes sense. Just in case it didn't, let's take a look at example 2. So in example 2, the input nums equals an array of integers 11, 13, and 31. The output is 9, 12, and 15. Boom. So explanation says for I equals 0, the smallest ANDs of 0 that satisfies ANDs of 0, bitwise OR ANDs of 0 plus 1 is equal to 11 is 9, because 9 bitwise OR 9 plus 1 is equals 11. So let's go through it. So once again, we have, so it would be 9 bitwise OR, open up the parentheses, 9 plus 1. So that's going to turn into 9 bitwise OR 10. Boom. So see, and binary 9 is 1001, and 10 is 101. Oh, sorry, y'all. 10 is 1010. Boom. So let's do the comparison. So 1, that's a 1, that's a 0, that's a 1, and that's a 1. That is going to equal 11. Boom. So that, now we know this 9 works, right? Or this 9 works, sorry. Boom, because that, when we do this operation on this 9, we get 11. Boom. So let's check 13. Or index 1. So it says for I equals 1, the smallest ANDs of I that satisfy ANDs of 1 or bitwise or ANDs of 1 plus 1 equals 13 is 12, because 12 bitwise or 12 plus 1 is equal to 13. Boom. So let's go through it. So we're going to say, so it would be 12 bitwise or, open up the parentheses, 12 plus 1. Boom. Sorry, y'all. Boom. Then that's going to turn into 12 bitwise or 13. So 12 in binary would be 1100. 13 in binary would be 1101. Boom. So when we compare these, we should get 13 or 1101. So let's see. We get, compare these, that's going to be a 1. Compare these, that's going to be a 1. Compare these, that's going to be a 0. Compare these, that's going to be 1. And that's equal to 13. Let's just so y'all can see. Boom. So long story short, that equals 13 like it's supposed to. So we know this 12 checks out. Now let's do it for 15. So for 15, that would be, let me see. Let me get rid of this. Boom. So that would be 15 bitwise or, open up the parentheses, 15 plus 1. Boom. Come underneath that. That would be 15 bitwise or 16. Boom. So when we do that, let's see. 15 would be 01111. 16 would be 10000. Boom. So when we compare these, make sure this is right. Should be, yeah. So when we compare these, hold on. This is 15. This is 16. When we compare these, we get 1, 1, 1, 1, 1, and that is equal to 31, right? Boom. How many ones is that? 5 ones, should be 5 ones. Yep, that equals 31. So this 15 checks out when we run this operation right here. Boom, we know it checks out, that equals 31. That's how we get, it gets us this 31 after we run 15 through that operation. Boom, so that's how we got this output, y'all, or that's how it works. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, the first thing, hold on, let me clean this up. The first thing we're going to do is we're going to transform each number in the input array independently. So we're going to say nums.map, open up the parentheses, we're going to say num in. Boom. Then we need to create a variable or default variable, and we're going to set that to -1 just in case we find no valid bit manipulation. So we'll come right here and we'll declare a variable called res, set that equal to -1. Boom. Then we're going to start checking from the least significant bit. So we're going to declare a variable called d, set that equal to 1. Boom. Now while the current bit d is set in nums, we can say while, open up the parentheses, num comma d, oh excuse me, not num comma d, num bitwise and d, so one and sign, d, sorry y'all, does not equal 0, then we're going to open up the brackets. And if this bit is set, we're going to subtract this value from nums. This effectively turns off the lowest consecutive set bit. So we're going to say res equals num minus d. Boom. Then we're going to move to the next bit to the left, or we're going to move the next bit to the left, and by coming right here, and we could just shift it by saying d less than equal sign 1. Boom. Now we just need to return the smallest value found by removing the lowest consecutive set bits, or we could return -1 if none applied by coming right here, and we could just say, sorry y'all, oh no, come right here and we could just say return res. Boom, y'all. That's all she wrote. Let's give it a run. Let's see. It's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.